things on error message annotation plugins for Haskell.
Right. So I've got quite a few slides, so I might start speaking rather quickly. If I start doing that, please feel free to slow me down. Just raise your hand or something like this. Right. So error message annotation plugins for Haskell. So as a sort of brief first overview, what are we going to be talking about? What is this? I'm going to be staring down at the ground the whole time. Essentially, I'll be outlining a new plugin interface that I'd like to propose. Its main task is that it should allow you to improve type error messages without actually having to hack directly on GHC. There's no formal proposal yet, and the reason for that is really that the changes are actually quite minor, but I do feel like there's quite a lot of input that you want to take from a bunch of people before you want to make a proposal about this, because it's going to evolve quite a lot long before you actually have anything concrete on a piece of paper. So basically what that means is this is still very early stages, so if you hear something that you're quite interested in, or if you hear something and think, by God, that guy's an idiot and he knows absolutely nothing, this is perfectly, please join on in and you can make modifications. Right. So, as a brief overview of what we're going to be going, I'll be going over first 5 sort of issues and goals, which are sort of noticed that this is sort of looking to tackle. Then we'll actually be detailing the, prior work will go first, then the error message plugin approach will be sort of detailed, then we'll go into implementation, time willing, and then we can show a couple of examples of plugins which have been built on top of this sort of new plugin interface. And then finally, we go into what's next. So the basic idea is that type error messages are hard, right? Now, I don't want to sound like a wimp when I'm saying that, but at the end of the day, it is actually quite an interesting problem, right? You've got people who are producing type error messages and people who are consuming them, and they've all got sort of slightly different goals or interests, which aren't necessarily at cross purposes, but sometimes might be pulling in interesting directions. So essentially the end result is that you need to sort of think about what are these sorts of unique desires of some of these different groups to see what you might be able to design. So first issue is one that we're all familiar with. Many beginners find Haskell types intimidating or difficult, right? I mean, as much as we all like to tell ourselves we're good at Haskell and things like that, everyone in this room at some point had to learn that a string and an int are different things, right? And for some of us it came on day one. Some of us, like me, spent 5 years writing JavaScript and had to have it beaten into us gradually. But so the sort of basic goal then that this issue creates is you want to give them better, more well-explained messages, right? Simple goal. Next, you have an issue, which is that it's going to be difficult to gather consensus on ideal error complexity. Some people are going to want, you've got a very large community of people who are consuming error messages. Some people are going to want, very, very fully detailed explanations of what is the error that they're encountering. An int is not a string, and a string is not an int. And other people are going to want something filled with jargon that they're used to, that they can quickly skim and really get the details that they want out of it. So really the goal that I took away from that is that you want something like an opt-in only model to avoid having to bring around the whole community on a single error improvement before you do it. Then you've got issues 3 and 4, which have to do mainly with library implementation, right? So when you have a library with very complex inner type machinery, we still have the problem that if then somebody uses that library, it's you have a surface DSL or something like this, in a way that doesn't type check, very frequently that inner type machinery is going to be revealed as the full header that it is. And this is type machinery which you probably haven't documented or probably haven't fully explained, and which really the person who's using the DSL shouldn't have to be interested in, because if they wanted to be interested in that, they wouldn't be using a DSL, right? So that's one issue. So you'd like probably to be able to hide some sort of complex inner type machinery when possible with custom errors. And then also, of course, complex inner type machinery is hard to diagnose, right? So you want to be able to provide as much information as possible for type error diagnosis. And then finally, this isn't really a goal, but or really an issue per se, but you know, GHC error generation is already pretty complex. So if we want to do something in this sort of sphere, probably don't, you know, go changing the entire system, you know, ripping things out and plugging things back in. Try to keep things relatively minimal when it comes to increasing complexity within GHC. So, right, so those are the sort of 5 goals and issues. You know, this is your goal summary map. These are the sorts of things that we have in mind, right? So, right, how do existing approaches sort of apply to this? If you want to tackle these sorts of goals and issues, what can you use in terms of existing approaches? Well, so you've got type error and unsatisfiable, which Simon really helpfully pointed out. The whole talk that I was listening to Simon, I was thinking, well, great, he's just preempting everything I'm saying. But, right, alas. So, you know, type error and unsatisfiable, for those who are not too familiar, you know, you can have a show instance on A to B, and then say if somebody tries to show a function from A to B, they then introduce this type error, right? And then that's going to be essentially a special message that gets injected or you know, thrown out when somebody tries to show a function from A to B. Now this is quite nice. Of course, the proposal for unsatisfiable points out a lot of the interesting issues with type error, but roughly speaking, it fits quite nicely with the existing mental model that people have of Haskell, right? As in, like, they are aware of class constraints that are introduced and then dispatched with, right? So telling them, oh, this is a type error that is a class constraint, actually works kind of nicely. And of course, it's an example of custom error messages. Fantastic. So great, you've got some of the functionality that you want out of this. Now, the DAML-C compiler, and this is where we sort of first encountered this problem, was at Digital Asset, we have this compiler for a smart contract language, which is essentially a DSL built on top of Haskell, right? But the problem was our clients use this DSL built on top of Haskell, and then they do something wrong, and all of a sudden they get the full Hydra internally, right? And they don't want that. So we went in and modified the compiler pipeline error message output phase. It was really easy to implement. We added basically a module, and that was it, right? Now that's nice, you know, in the sense that you haven't made too many changes to GHC. So it fulfills that goal 5, but of course, you know, you did have to compile in your logic. So you're not really going to get this to first years who are learning Haskell for the first time. Because, yeah. Elm is another kind of interesting example of something that we can learn, that you can learn from, or that can give us some thoughts about the goals and issues. Elm has well-detailed errors, incredibly well-detailed errors, right? And then combines them nicely with source locations and details all the mismatches, but really detailed, right? As in, like, it tells you about the flow of the types through the pipeline and things like this, right? It really has this sort of flowery view of the world, and it's trying to bring that type level world down to the person who's ultimately just trying to build a user interface. So, and of course, what's nice is that they document their ideas on type error emission. So that's quite nice. It sort of fulfills goal 1. Then you've got the Haskell language server, which does a bunch of really useful stuff in that it pulls info out of errors, it pulls a bunch of information out of each individual stage in the compiler pipeline, and keeps them all around so that I can helpfully provide more and more information to the IDE. So this is useful, but also what's useful about the Haskell language server is it has a plugin interface, right? So you can write plugins for the Haskell IDE. So now you no longer need to get everybody's consensus before you try to improve LSP for Haskell, right? You can write a plugin, give it to your friends, and they tell you it's good. And at no point did you have to force everybody come along with you. So that's something to sort of take away. And then you've got, you know, another example is the Helium compiler. I don't know how many, who's heard of the Helium compiler? Okay, good, fantastic. Right, so, you know, built from the outset to have a core that can be extended a little bit more easily, provides a lot of extra information for more in-depth error analysis. Really just sort of is useful in the sense that they provide a lot of information, right? For diagnosing these really complicated type error messages. So what do you get out of these approaches? I mean, each of them give a bunch of useful takeaways, right? The compiler changes to integrate well with existing messages, right? DAML-C, you want to isolate your changes. Type error says that, you want to trigger your custom error logic when you detect certain patterns, because that way it doesn't get too complicated. The Helium compiler, gets some information out there, and HLS tells you, okay, a plugin model will help solve this consensus issue. So, great. So then we try to bake these sorts of ideas, and just 5 left. Okay, well, so we put them all together into the error message plugin approach. Oh boy, okay, well, turns out I talk a lot slower when I'm on the podium. Anyways, yeah, so for those of you who aren't familiar, GHC has a plugin interface where you essentially define a plugin module and then you can, inject it into the pipeline, right? So this will now change the type checking behavior of the pipeline, right? So our proposal then is to add a new handler, error message plugin. So this triggers when a message is emitted. So this is essentially your pipeline. Your type check is going to occasionally emit a TCRN message. That's sort of the error, right? I mean, there's a bunch of other structs, but let's keep it simple. So we propose instead, you can add an error message plugin which can intercept and rewrite these error messages, right? So why is this useful? Well, if you assess it according to the sort of goals, right, which each of those previous approaches were sort of getting at, you get some nice results. You can annotate or wholly replace error messages, so you can actually give users better, more well-explained messages. You can provide as much information as possible for type error diagnosis. You're running during the type checking phase. You have basically as much information as you're going to get. You don't really increase the compiler complexity too much. When we implemented this, it came out to about 100 lines, and most of it is boilerplate for anyone who's written a GHC plugin. And then for libraries, you can effectively hide complex inner type machinery. And then finally, all the plugins are opt-in, so you don't have to deal with the consensus issue. So, right, implementation, you know what? Anyone who's written a plugin, or there's plenty of blog posts out there telling you how to write a GHC plugin. So this is going to look pretty simple to most people. You have an initialization phase, and each error message plugin creates a rewriter. And so a rewriter takes a renamer message and then produces a rewrite. And this rewrite just gets attached to it inside of a struct. So it gets injected inside there, and what this means is that future plugins essentially can look at what was the error message before we rewrote it, before we annotated it. So once it's rewritten, we add this new variant, and by keeping the old message, all plugins can ignore the changes of previous plugins or use them to help inform them. Yes?
Just to be clear, so go back a slide.
Mm-hmm.
So that thing TCRN message, that's the existing algebraic data type for the message, is that right?
Yeah.
Okay. And so then you're gonna and your rewriter doesn't change that at all, you're saying, it just returns some extra information in this TCRN message plugin rewrite, is that right?
Yeah, it essentially injects a little bit of extra information. So we've also got a TCRN message detailed info is sort of a similar pattern where you wrapping a TCRN message with additional state to help pretty print it differently, essentially, right? So we can jump to where we actually report the diagnostics. You can see here we actually, whenever we get a new rewrite, we just inject it alongside the original message inside of this struct. I mean, I'll make these slides available,
But ultimately, what effect does ultimately that have? That
Well,
it gets rendered somehow in the end.
Yeah, so in the end, the side effect is that when the pretty printer triggers, it will, depending on this rewrite, either attach a bunch of additional information and some additional hints, both can be null, or it can wholly change the original type checking rename message. So the pretty printer will, when it sees a rewritten plugin message, right, a rewritten TCRN message, will pick up this information to figure out how should it print it. So the kind of nice benefit of this, right, is now you have essentially an interface by which you can change the error messages that GHC produces, or you can just annotate them with additional information. But you have this sandbox now. So now if you want Elm errors, Elm-like errors, for example, you don't need to tell the GHC compiler team, oh, this is my merge request. These are all of the changes. I promise that I will maintain them. You can build it as a separate plugin. GHC doesn't need to interact with it at all. It just needs to provide this interface, essentially. Yeah. There's a few examples. A Haskell error index plugin. It attaches a blurb for the error code. So it just is a plugin which finds this error code and then injects in some additional information for the error code. So it pulls out the blurb from the website. You have the same for GHC has field struct errors. You can always detect things for no instance shape and just attach a little bit of information that says, this is what it actually means. The field Z is not defined on point 2D, and these are the structs in scope that might have such a field. Similarly for specific libraries, right? So now if you have a library with complex intertype machinery, I mean, Lens is sort of stretching that definition, but it still works. If you try to use a prism as a lens, right, the error that you get is incredibly instructive. It tells you that you don't have a monoid instance, right? So for this, it's actually quite nice because you can write a plugin which just says, am I seeing a lack of monoid instance? Is the origin from an identifier that was imported from the Lens library, right? And potentially with a little bit more information inside of constraints, you can, with potentially a little bit more information stored inside of constraints, you could even figure out that, oh, that monoid instance comes from the fact that we're trying to solve an applicative instance, which we're trying to solve because we're trying to get a choice profunctor, something like this, something that is classically Lens-like. So the result then is, well, oh, okay, so one slide got dropped, but point is here it injects a message which says, looks like, just like Clippy would, it comes up and says, looks like you're trying to use a prism as a lens. Would you like to change that, right? Would you like to use !? instead of !. So that's what you would see down there if I knew how to create PDFs. And then of course, you can also use this for shenanigans. A few days ago, I thought to myself, well, here's something fun you could do. You could emulate the good old days when errors were screamed, right? Like, you've got this old quote, I don't know if anyone's familiar with it, real programmers don't write Pascal, or write in Fortran. As this quote, a real programmer said things like do 10, I 110, and append, and they actually talked in capital letters. Well, now you can get GHC to talk to you like a real programmer, right? And what's nice is that these plugins actually stack, right? Because they can always inspect the old error message. So when I was first testing this out, it also screamed all of the additional advice that the GHC error message index was giving me, all that stuff. Right, so that's sort of the list of examples. So what's next, essentially, right? So I have this idea that this interface, if available, would be a pretty nice test bed for error messages in the wild, right? You wouldn't need to develop a hypothesis and then, well, you would be able to develop a hypothesis, maybe this error message is better, and then test it on your students without ever having to say, compile GHC from source with a patch, right? But there's definitely other things that I'd like to explore before, committing to a proposal, namely, we'd like to rewrite errors from other phases, right? First years make other mistakes than type errors. They write case, but where the E is in the middle of the word, right? And then they get confused and they send you an email late at night. Additional information from the type checker environment to help the rewriters. What sorts of additional information would you want in scope is also kind of interesting. What sorts of hurdles will you have for adoption by library implementers, right? So say you did want to make a specific plugin for making lens errors more readable, right? Optics notwithstanding. What sorts of things would need to be available for the rewriter to actually be able to make that feasible? Then you've also got the simple question of, what is a simpler user error? What is a user error that students will find interesting? And that's just a wholly separate project, obviously, once you have such a plugin interface. And then just getting more and more examples, right? I can't think up many more weird ways of rephrasing your type error messages. There's screaming them, there's saying them like an anime character. I got that working the other night, and that was, useful, but, no. But so, yeah, more examples for testing the limits of the implementation as it currently stands. So that's where I come to you guys. We've got, a couple of forks. It's 100 lines of code. It's really quite small. The examples are much larger than the actual changes to GHC itself. Feel free to take a look. Tell me where I did something terribly wrong. And thank you very much.
Time for one question.
Oh, sorry about that.
Is this working? Yeah. So the question is, how do the users enable these plugins? Should they enable another plugin for every transitive library of your program that might need to enable custom error messages?
I mean, it depends. I mean, that sounds like a build system issue, right? I mean, more than anything else, right? Like, if somebody told me to do that, I'd be more worried about how I'm going to rewrite the Bazel and the make file than the plugin's capabilities. But in brief, I mean, yes, but I anticipate most of the benefit to someone who's developing anyways is those first order errors, right? The ones where you're depending on directly on a dependency and you've misused it somehow, and now it's angry at you and you don't know why, right? Yeah. I'm only here for today, so if you do want to talk to me about this, I'll be available the rest of the day, but make sure it's today. Yeah. Thanks a lot.